Wrong theories aren't swept under the rug. They're signals that we're learning, tinkering, and getting closer to the truth. Myth 21 says a theory that turns out false means it was simply hidden away until someone forgot about it. In reality, when an idea flops, scientists ask what went wrong, refine the idea, and run new tests. It's like debugging a recipe. If the cake sinks, you don't burn the cookbook, you tweak the ingredients, bake a bit longer, and try again. Or think of your GPS giving a goofy location. You don't assume the world moved, you update the map. This video shows simple examples from everyday life and a few science moments, all to show how false results actually push us forward. If you want to understand how real progress happens and how to spot bad headlines that pretend failure means fraud, stick around. Debunking the rug myth. Many people cling to the idea that a false theory is simply swept under the rug. In reality, science moves by doubt, tests, and updates. When data disagrees, researchers recheck, adjust, or replace the idea. The rug myth treats mistakes as dirty secrets, but scientific progress treats them as stepping stones. Sometimes part of an old idea still helps, but only within new limits. It's like cooking. If a recipe misses the mark, you either tweak the ingredients or toss the dish, not pretend it never happened. Debunking the rug myth means showing how wrong it is to think refinement equals erasure. The process is gradual and open, not secretive. A theory might be kept in certain areas where it still explains things, while other parts are replaced. For example, our understanding of light evolved. We no longer force it into one box, but use a picture that allows both wave-like and particle-like behavior. That isn't erasing the old idea, it's expanding it. People sometimes confuse a revised view with a failed one. Social and cognitive biases help the rug myth survive. If a bold claim makes headlines, it's easy to forget the checks that came after. Scientists sometimes publish corrections and retractions, and that is a sign of honesty, not a cover-up. In everyday life, people may cling to a convenient belief because admitting error feels tough. A practical view is that truth evolves, not because someone hid something, but because more data came in. We can laugh at dramatic misfires and keep learning. To spot the rug myth, ask how strong the evidence is and whether predictions still hold. If a claim was wrong once, does it still help in some situations, or has it been tossed entirely? Look for independent tests and whether the theory can explain new observations. Notice whether a newer idea actually replaces the old one or simply adds a new layer on top. In short, scientific progress is a relay race, not a mock job. Mistakes are handed off, not swept away. Reactions to a theory's failure. A common fact about failures is that they trigger a mix of emotion and strategy. When new results contradict what people expect, cognitive dissonance can pop up, and the instinct is to reduce that tension quickly. So colleagues, funders, and even journalists often shape the story to fit what they already believe. It can feel safer to defend the idea than to admit it didn't pan out, like arguing with a GPS that keeps insisting you should take a scenic detour to a lake you know isn't there. Rationalization takes center stage. Supporters highlight the rare exceptions, point to quirks of the setup, or claim the problem lies with the test rather than the theory. Negativity bias nudges the conversation toward blaming the experiment rather than the idea itself. A simple life example helps. A popular diet fails to deliver for most people, yet fans insist the method works if you follow a stricter plan or adjust the timing. The pattern isn't about truth alone. It's about keeping a narrative intact when the data don't cooperate. Institutions contribute their own dynamics to the drama. Labs rely on funding, and negative results often have less shine than exciting headlines. So the push to publish can tilt toward the hopeful story. Publish or perish vibes make it easy to frame a downturn as a stepping stone rather than a setback. Sometimes a failure is tucked into a footnote or explained away as a necessary detour, not a dead end. Individuals may drift toward retreat or redirection instead of a direct reckoning with what the evidence says. Yet failures can become fuel when handled well. A healthy reaction is to revise the idea, test a new version, and be explicit about what still holds and what doesn't. Clear reporting, Openness about procedures and honest sharing of null results help the next attempt avoid the same mistakes. Replication, pre-registration, and transparent data are practical steps that keep the learning honest. Humor can soften the sting. Crashes happen, and sometimes the best part is discovering a better route afterward. The real win is turning a stumble into a smarter approach, not pretending the tumble never happened. Falsification, scrutiny, and reframing. The idea behind falsification is to challenge claims, not to crown them as forever true. If a theory keeps surviving attempts to disprove it, it gains trust, but the goal is always to test it under new conditions, with fresh data and open eyes. When a test fails, it's a nudge to look closer, not a verdict that the entire idea is junk. In everyday terms, think of a recipe that says add a pinch of salt. If the soup tastes flat, you don't pretend the recipe never existed. You try a bit more salt or a different ingredient and see what changes. Scrutiny means watching for mistakes, bias, and hidden assumptions as we test a claim. It means repeating experiments, asking someone else to run the same test, and checking if the result holds when conditions shift, like trying the same shortcut in a different car or with a different group of people. Scrutiny digs deeper. In daily life, this shows up when a health claim says if a supplement boosts energy. You want independent studies, not just a flashy blog post, and you check who paid for it and how many people were involved. Reframing changes the question, not just the answer. When data conflict with a theory, scientists can narrow the theory, expand its scope, or propose a new idea that explains the wrinkle without discarding everything. It is like adjusting a map to include a new road you discovered. A practical example is learning that kids' behavior and sugar intake might be linked in limited settings. Rather than saying sugar causes hyperactivity, researchers might frame it as sugar may affect short-term activity in some children under stress, which helps design better studies and policies. False theories aren't swept under the rug. They're candidates for revision. The process of falsification, scrutiny, and reframing helps ideas become clearer, more useful, and less likely to mislead, which matters when we make decisions about health, safety, or money. When a claim sputters, we test again, not retreat. In everyday life, that means checking shopping claims, questioning bold trends, and being ready to update our beliefs when new simple evidence shows up, with a smile and a sense of curiosity rather than stubborn pride. From error to progress, ideas about how things work are tested against what we observe in the world. When a test contradicts a theory, it isn't proof that the idea is rubbish. It's a signal to re-examine what's assumed. We don't sweep mistakes under a rug. We bring them into the light and ask what changed. That shift from error to insight is how progress happens. Take a simple kitchen moment. You try a method that says lemon juice should brighten a sauce, but your palate tells a different story. You tweak the recipe, test again, and suddenly you have a version that actually tastes right. Not every trial lands, but each one teaches you something about balance and timing. In science, the same pattern plays out on bigger stages, with ideas about how the world works being tested against real results. Science moves forward by testing, repeating, and sharing what happens, even when results don't match the original idea. If a false belief keeps showing up in many situations, it's a clue to look for missing details or by steps. Sometimes false theories push researchers to ask new questions they wouldn't have asked otherwise. That kind of error isn't a dead end. It's a cue to refine, adjust, or replace the idea with something that fits more of the data. So the rug idea misses a big point. Mistakes aren't hidden, they're used. Error becomes a prompt to check assumptions, gather more evidence, and try a different approach. In everyday life, this looks like revising a recipe, updating a plan after a failed forecast, or testing a new habit until it sticks. In a broader world of ideas, it means progress by cleaning up what's uncertain, not pretending the mess never happened. When theories turn out false, the real story is that the wrong path was spotted early enough to guide us to something better. Real-world case studies. Lessons learned. Real-world case studies show that false theories rarely disappear quietly. They often glitter at first, then disappoint when people look closely. Take the polywater episode as an example. Researchers claim to have a form of water with strange properties that could bend the rules of chemistry. Labs around the world chased the idea, reporting dramatic results that sounded convincing. Yet, independent replication failed, and the initial excitement faded. The lesson is clear. Extraordinary claims demand strong, verifiable proof and transparent sharing of methods. In everyday life, this shows up when a trendy remedy or miracle diet grabs attention and then collapses under scrutiny. The rug metaphor invites a quick loss of faith, but the real pattern is about building a habit of rigorous checking rather than sweeping anything under. Cold fusion illustrates another striking case. The promise of simple, safe energy grab headlines and budgets, stirring enormous hope. Proponents claimed a simple setup could spark fusion at room temperature, and the news spread fast. When other labs struggled to reproduce the result, confidence waned, and the need for independent confirmation rose to the top. The lesson sticks. Early zeal is not a substitute for repeatable experiments. Hype misleads people and redirects resources. In everyday life, people chase unverified success stories too, only to watch the claims crumble under closer examination. A practical takeaway is to demand a clear, repeatable protocol and to be wary of selective reporting. The luminiferous ether example shows how a good-looking theory can lure researchers into a comfortable frame of mind until sharp tests push back. The idea was that light needed a medium to travel through, but precise experiments failed to find evidence of such a medium. Later, a new framework for understanding space and light took the stage, and the old idea quietly retired. The lesson is simple. Be ready to adjust big beliefs when experiments don't cooperate. In everyday life, it pays to test the simplest explanations first and avoid clinging to an elegant story just because it feels tidy. Spontaneous generation and the old phlogiston idea remind us that science grows by testing and falsification, not by avoiding inconvenient results. Spontaneous generation suggested life could spring from non-living matter. Careful experiments showed otherwise. Phlogiston explained burning away as something losing a substance. Better explanations arrived once measurements and observations improved. The moral isn't about blame. It's about curiosity and careful checking. In daily decisions, testing assumptions with small experiments helps too. Try a recipe, see if it works, adjust if not. The big takeaway from these stories is that truth emerges through replication, openness, and patience, not through brushing messy questions under a rug. Science as a conversation, sharing evidence. Science works as a conversation where evidence is shared and debated, not a final stamp of authority handed out by a single person. Evidence means data you can see, measure, or observe. When new data clashes with an idea, the response isn't to hush it up, but to test again, question the methods, and refine the idea so it fits better. That's how understanding grows. If a theory misses the mark, scientists don't pretend the mismatch never happened. They treat it as information that needs explanation. The goal is a clearer map, not a confident rumor. Sharing the evidence openly lets others test, try new experiments, and point out what the data really shows, which helps everyone avoid blaming the messenger. Mistakes become stepping stones. Researchers publish results, share data sets, and invite others to reanalyze methods, which keeps the discussion alive. Peer review, open data, preprints, and talks are all parts of the same conversation. When a claim is wrong, the conversation continues with corrections, replications, and new studies that add more evidence and a better sense of what works. This is how science self-corrects. Think of science like swapping recipes with friends. You try something, it tastes off, you share notes, and everyone suggests tweaks. If a dish flops, you don't hide the burnt pan. You tell the story so others don't repeat the same mistake. Similarly, when evidence changes, guidelines, theories, or models shift, and the conversation moves forward with better tools and clearer pictures. That is science in action. Bottom line, when a theory turns out to be false, it doesn't mean someone swept it under a rug. What actually happens is that new data, better experiments, or fresh observations push scientists to revise, refine, or even replace that idea with something that fits what we now see more reliably. Think about everyday life. A recipe misses the mark, so you tweak the ingredients or try a new approach next time. Weather forecasts get updated as new readings come in. Your phone gets a software update because developers found a better way to fix bugs. These tweaks aren't cover-ups. They're improvements based on real-world results. If you've ever worried that science is just a stack of permanent mistakes, you're not alone. But this is where the learning part shows up. Mistakes aren't final verdicts. They're clues that push us toward a better explanation. If this video clicked with you, give it a like and consider subscribing for more myth-busting without the hype. Drop a comment with a theory you've heard that seemed disproved, and we'll unpack what actually happened. Share this with a friend who loves to learn without getting lost in jargon. Next up, we'll unpack how scientists decide when to change a theory and what evidence actually means in simple terms, plus a few more myths from everyday life. Thanks for watching. See you in the next one.